Welcome to Spring LIB.
Okay, we need to find the way in which the 2 microfarad capacitor gets the minimum of potential drop. Let's consider the circuit combination which is completely in series. As we know, series capacitance is the least. So if you try to find the series capacitance of this system here, you'll find that net capacitance is 0.67 microfarad. You can perform this calculation and confirm by yourself. Now, charge deposited on this system is given by Cn times V, which is 0.67 times 12, which gives you answer as 8 microcoulomb. Since we know the net charge deposited, and as we know in series circuit, charge deposited on each of the capacitor plate is same. So we can use that information to find out the potential difference on 2 microfarad given by Q divided by C, Q being 8, C being 2. Since both of them are in micro units, the net answer is 4 volt. So as now we know that in this particular circuit, we get the value 4 volt across 2 microfarad capacitor. Now let's consider another kind of circuit in which 1.5 microfarad capacitor is connected in series to the parallel combination of 2 and 3 microfarad capacitor. So as we know in parallel capacitance increases, so 2 and 3 microfarad capacitor gives you the value 5, and in series with 1.5 gives you net value of 1.15 microfarad, so that you can find the net charge Q, which is equal to Cn times V, that is V being 12. You can find the net charge is 13.86 microcoulomb. Now here's a trick. You need to understand that how much of this 13.86 microcoulomb is deposited across 2 and 3. Since 1.5 has 13.86 microcoulomb because it's in series, but in parallel circuit that behaves bit differently. In parallel circuit, whichever has the more capacitance has the more charge. So, but how do we know how much? To find that out, you need to just divide 2 by 5 here, as I have done here. So this gives you 2 by 5q, and this gives you 3 by 5q. Since we are interested only in 2 microfarad capacitor, we will only perform the operation given here, which is 2 by 5 times q, which is q value was from the first page here 13.86. So 40% of 13.86 is 5.54 microcoulomb. So the potential drop across 2 microfarad is given by charge divided by its capacitance. Charge here is 5.54 microcoulomb and the capacitance here is 2 microcoulomb. We find that the charge potential drop across 2 microfarad capacitor is 2.77, which is less than what we found for the complete series circuit. Let's try out one more combination, that is 2 microfarad in series with 1.5 and 3 being in parallel. If you find the net capacitance of this circuit, it is 1.38, which is higher than what we obtained before, which is 1.15. Now 1.38 microfarad gives you charge deposit of 16.6 microcoulomb, and as we know, the system in this system, the parallel circuit of 1.5 and 3 has the charge of 16.6, and 2 microfarad capacitor also has a charge of 16.6. So this combination will give you the charge of 8.3, which is very high. Now we will consider a last combination of this circuit. In this case, you can find that the net capacitance is 1.61 microfarad. So you can find charge as Cn times V. Again, voltage is 12, so 1.61 times 12 gives you 19.32. Now you can easily guess that 19.32 charge is given to 3 microfarad capacitor because it's in series, and to the 3.5 resulting capacitor, 3.5 microfarad of resulting capacitor also has 19.35 microcoulomb of charge. Now, as we did before, the net charge on 2 microfarad capacitor is given by 2 divided by 3.5 times Q, which is equal to 11.04. If you now find the voltage drop across 2 microfarad, you get 11 divided by 2, which is equal to 5.5, which is also higher than the combination that we discovered before. So the minimum capacitance that minimum voltage drop that we can achieve across 2 microfarad capacitor was in the second combination, which is given by 2.77 volt. Thank you.